I've created a 3D Rubik Cube simulation using Python as a programming language. I used PyQt5 to create a window, and I add a few buttons at the side. Moderngl framework is used instead of OpenGL because of its simplicity. Even though it is fairly new and don't really have a lot of tutorial out there, I definitely recommend checking out the GitHub page and learn from the examples. The first feature is rotating of the whole Rubik cube using Trackball. It is such a common feature, but you have to code it yourself, as it is not provided by the moderngl framework. The input I have is just the XY coordinate of the screen. Let me set the radius of this trackball to be 1. If x and y is the side of the right angle triangle, d is the hypotenuse. If d is smaller than 1, it means the mouth is inside this 3D trackball. Using Pythagoras theorem, we can calculate the value of z. If d is bigger than 1, it will locate over here, and z will be set to 0. In this way, we are getting the vector coordinate of the mouth on this 3D trackball, which is P1. We can calculate the angle of rotation by dot product between P1 and P2, as well as the cross product to get the axis of rotation. Thus, given the angle of rotation and the axis of rotation, and feeding into the standard function, we can get the rotation matrix. Next, I will talk about 3D picking. Given the xy coordinate of the mouth, you have to know what's the ID of the cube that is picked, so you can decide what the user is trying to do using the mouth. Over here, we have the 3D world space and the 2D screen space. The transformation between the two spaces is done by matrix multiplication. We set the camera positional world space to be PC. From the xy coordinate of the mouth, you can get the world coordinate by setting the z to be -1. In this way, we are getting the line equation of this dotted line over here. This technique is also used by shooting games like PUBG to calculate the trajectory of the bullet. Using equations found from this Stack Overflow page, you can calculate the distance d from mouth to the plane occupied by 3 dots, A, B, C. Everything you see in the 3D graphic are drawn using triangle, using 3 vertex coordinates. When you know d, you can substitute into the line equation to find the coordinate of pi, which is the intersection point between the plane and the line. You've seen this technique found from the Stack Overflow page. You can check if the point pi is indeed inside the triangle ABC. There is an invisible layer over the Rubik cube. It only gets rotated when the whole Rubik cube is rotated. It doesn't change when the single layer of the Rubik cube is rotated. Mentioned earlier, computer needs to check all the triangle to identify which cube it is hovering over. To avoid checking as little triangle as possible, it only has a single layer of triangle instead of a complete cube. Each of these invisible cubes has ID attribute. They are organized in 3x3x3 numpy array. In the first layer, it has ID 1 to 3, followed by 4, 5, 6, followed by 7 to 9. If I move my cursor like this, you're always telling me the 7, 8 cubes are selected, no matter the exact orientation of a Rubik cube. You always rotate the first layer in the anti-clockwise direction. The second layer Rubik cube, which is the actual visible cube, are also organized in 3x3x3 numpy array. If you want to rotate a cube in this way, all the cube numbers in the first layer, namely 1 to 9, are selected. We have to individually select the cubic number and change it from the left to right. The code is shown here. Lastly, we only have to apply the correct orientation matrix to the correct groups of cubes to achieve this amazing Rubik cube effect. Sadly, it is very hard to cover all the nitty-gritty details of my implementation. Definitely check out the code if you want to know everything. Thank you. Here are some of the examples of my frustrating times.